If time is just another dimension of the universe, why does it feel like a one-way road? Why can we remember yesterday, but never tomorrow? Why does a broken cup never leap back into our hands? Why does smoke never return to the fire? And why do our lives move forward, even when the laws of physics do not demand it? If the universe is governed by equations that work the same forward and backward, why does time insist on flowing in only one direction? This is not a poetic question. It is a scientific one, and it has quietly troubled physicists, philosophers, and cosmologists for over a century. We know this much. Time is woven into every physical theory we use to describe the universe. It is the quiet framework behind motion and change, the invisible axis along which cause becomes effect. Without it, nothing happens. No star ignites. No galaxy gathers itself from scattered dust. No planet cools enough for life to take hold. Time gives the universe sequence. It allows processes to unfold rather than exist all at once. It is why explosions spread, why heat flows, why history accumulates instead of repeating. And yet, when we look deeper, when we strip reality down to its most fundamental rules, something unsettling appears. The laws themselves show no preference. At the level of fundamental physics, almost none of the equations demand a forward direction. They function just as well if time is reversed. Particles collide the same way. Forces balance the same way. The mathematics remains perfectly intact. From the universe's most basic perspective, yesterday and tomorrow appear interchangeable, and that single fact should disturb us, because everything we experience insists otherwise. Here is the contradiction at the heart of time. In every human experience, time moves in only one direction. It does not hesitate, and it does not reverse. We grow older without exception. Bodies wear down. Structures weaken. Moments pass and never return. Memories pile up, layer upon layer, but they are never peeled away. We remember the past precisely because it is gone, and we recognize the present only as it slips into history. Time, as we live it, is irreversible. And yet, when we descend to the smallest scales of reality, that certainty dissolves. At the level of fundamental physics, there is no preferred direction at all. Atoms carry no record of what came before. Particles do not lean toward what comes next. The basic equations that govern the universe are indifferent to past and future. Run them forward or run them backward, and the laws remain perfectly satisfied. From nature's deepest perspective, time has no arrow. So where does ours come from? If time itself contains no built-in direction, why does every experience insist that it does? Why does the universe we inhabit feel so different from the universe described by its own equations? This is the point where certainty breaks down. This is where explanation gives way to possibility. And this is where the hypotheses begin. The most familiar explanation for the arrow of time is entropy. Entropy is often described as disorder, but that word can be misleading. At its core, entropy is about probability. It measures how many ways a system can be arranged while still appearing the same from the outside. Systems naturally evolve from rare, highly specific configurations toward states that are far more likely, simply because there are so many more ways for them to exist. A perfectly ordered deck of cards is fragile. One shuffle destroys that order instantly, because there are millions of possible disordered arrangements and only one exact sequence that counts as pristine. The reverse is not forbidden by physics, but it is so statistically unlikely that it effectively never happens. The same principle governs the universe. Ice melts into water. Stars burn through their nuclear fuel. Complex structures gradually break down and settle into equilibrium. In each case, the system is moving from a less probable state to a more probable one. Time, in this view, appears to flow forward because entropy increases. And entropy increases because probability overwhelmingly favors it. But this explanation carries a profound problem. Entropy can tell us how time seems to move, but not why it began moving in that direction at all. For entropy to increase, the universe must have started in an extraordinarily low entropy state. And no current theory can fully explain why the cosmos began so improbably ordered. That question remains open. Another proposal is far more unsettling, because it challenges the very thing we trust most: our experience. Perhaps time does not flow at all. Perhaps what we perceive as the steady passage of moments is not a property of the universe, but a construction of consciousness itself. In this view, the universe is not unfolding. It is complete. Past, present, and future all exist together within a single, unchanging structure, often described as a block universe. Nothing truly moves through time. Events do not advance. Instead, what changes is our position within this fixed cosmic landscape. We transition through different configurations of reality, carrying memory from one state to the next. Time feels as though it has direction, because memory has direction. We remember earlier states, not later ones, and that asymmetry creates the powerful impression of flow. But this explanation introduces a deeper discomfort. If time is only a feature of perception, then the universe should be indifferent to observers. And yet, even in the absence of consciousness, stars continue to evolve, galaxies collide, and black holes slowly evaporate. These processes unfold with or without witnesses, governed by physical laws rather than awareness. An illusion of time may explain experience, but illusion alone cannot account for a universe that changes whether anyone is there to notice it. The third hypothesis is the most radical, and perhaps the most promising, because it asks us to reconsider what time actually is. In this view, time is not fundamental. It is not a basic ingredient of the universe, but a secondary phenomenon that emerges from deeper, timeless laws. Much like temperature arises from the collective motion of countless atoms, time may arise only when systems become complex enough to register change within themselves. At the deepest level of reality, there may be no ticking clock at all. Instead, there are only relationships between events, correlations among physical states, and flows of information. Nothing progresses, nothing waits. The universe simply exists as a network of connections. Time appears only when parts of that network begin to compare states, store records, and recognize difference. The arrow of time, in this sense, is not written into the fabric of the cosmos. It grows out of the structure of reality as complexity increases. But if time truly emerges in this way, then it may not exist everywhere, or always. Under extreme conditions near black holes, at the beginning of the universe, or at scales we have yet to observe, the familiar flow of time could break down entirely. And if it does, our deepest assumptions about reality may have to break with it. One observation could change everything. Not a new philosophy, not a clever metaphor, but a single piece of evidence capable of breaking our assumptions. If we discover that time behaves differently where quantum mechanics and gravity intersect, then the arrow we take for granted may no longer be fundamental. If we observe regions of the universe where entropy can decrease in isolation, even briefly, then irreversibility may turn out to be a statistical illusion rather than a cosmic rule. Or, if spacetime itself is shown to be emergent, something that arises from deeper structures rather than forming the stage on which reality plays out, then time may lose its status as a primary feature of the universe. The direction we experience would no longer be mysterious. It would be the natural outcome of underlying processes, not a built-in law. But for now, such evidence remains beyond our reach. What we are left with is a universe governed by equations that do not care about past or future, yet somehow produce lives that cannot be rewound. A cosmos that is, at its core, timeless, but gives rise to stories, memories, and endings. Until that one observation arrives, the arrow of time remains unexplained, quietly shaping everything we are, while refusing to reveal where it truly comes from. If time truly has no preferred direction written into the universe, then why does every moment feel as though it vanishes behind us? Why does the present seem so fragile, slipping into memory the instant we notice it? We know the equations. We can write them down, test them, and trust their precision. But experience does not fit so neatly. The mathematics remains silent where human intuition speaks the loudest. We live in a universe that describes time as symmetric, yet we feel it as relentless and one way. Scientists offer possibilities: entropy, perception, emergence. Each explains part of the picture, and none explain it completely. Any single discovery could force us to rewrite everything we think we know. But until that moment arrives, the question remains open, suspended between what we can calculate and what we cannot escape. At Deep Space Inquiry, we are not here to chase easy answers or tidy conclusions. We stay with the questions that refuse to settle, because those questions often point toward deeper truths. Sometimes, wonder itself is the signal that we are close to something real. And perhaps the deepest truth of time is not that it moves forward, but that it gives meaning to our lives, precisely because it never turns back. Time may not belong to the universe, but without it, nothing we love would ever matter.